Hi, welcome to this video on artificial intelligence where I discuss about the four core domains of artificial intelligence. So let's continue. In this video, I'm going to discuss some of the very fundamental questions like what are these four different domains of artificial intelligence? What are their capabilities? How they are used? While explaining that, we will also take one use case for each of these domains to understand on ground how they are bringing value to the businesses. Number three, we are also going to look at what are the basics that are going into implementing these systems in the real time. So by the end of this session, you'll have a good understanding about the core domains, some of the pertinent examples, and basically what goes into implementing these systems. So here we are. Before we go into this list of the core domains of AI, I'll ask you a very fundamental question. What is artificial intelligence? So artificial intelligence allows us to build systems that are able to learn from data and be able to make predictions, make autonomous decisions, and nowadays also be able to create content. Learning from the data is a fundamental capability that these systems offer. And based on that data itself, you can find out how the four core domains of artificial intelligence are divided. Let's go through this list. Number one, if you're dealing with a problem that involves structured data in the form of a database table or an Excel sheet, and you want the systems to understand this data and be able to make predictions or decisions, then machine learning is the domain that we'll use to solve that problem. Number two, if you're dealing with the data that is in the form of human language and that too in the unstructured format, and your problem is to understand this data better and also be able to generate insights that will help you to take certain actions, natural language processing is the domain for you. Number three, if you're dealing with the problems concerning the images and videos, then computer vision is the capability that you're looking at. And finally, if you want to go beyond the analysis and predictions and actually delve into the area where you want system to generate content, let's say in the form of the text or images or code or videos, then generative AI is the domain that helps you solve that problem. To understand each of these domains better, let's look at some of the practical use cases, how industry is using this technology to improve the ways in which they work today. First amongst these is the example for machine learning, where we talk about an example from retail industry, and it is to do with demand forecasting, the demand forecasting for a product. A typical challenge for a retailer is they struggle with stockouts and the excess inventory, and both of these scenarios you will be able to imagine leads to loss to the business. The solution that comes here is to be able to predict demand for a product in the future. If you can get that insight about a product demand in the future, naturally it helps you manage your inventory better and thus be able to solve these problems of a stock out and excess inventory. So this solution has indeed led to 15% increase in fill rate and 20% reduction in the excess inventory in one of the cases that I have captured here. To implement this kind of a system, what goes in architecturally is number one, you collect data, you collect historical records from that store about their sales, the pricing of the products, the holidays, and the promotional events that all are impacting the sale of that product. So we get the historical data from that store, put it in a structured format like a table or a spreadsheet, move on to the next stage where we choose a machine learning algorithm, which I said are capable of understanding the patterns that are exhibited within this data. So these algorithms would learn, looking at the examples from data, how the input parameters like the pricing or holidays or promotional events are impacting to the sale of a particular product. And once it understands that, you can go to the next stage where you expose it to the new data, which is input data of the future, and the system will be able to generate the forecast for that product's demand in that period. So this is a basic workflow in which a machine learning system is developed and implemented. Let us move on to the next example. It is about natural language processing. And the use case that we picked up here is from a telecom industry, and it's called sentiment analysis. So the challenge here, the telecom operators, they have huge number of customers, and on a daily basis, they keep on getting customer reviews, comments, complaints coming to their way for their teams to analyze and to be able to address the customer's need. You will also be able to imagine it must be taking a lot of manual effort and time before this kind of analysis from such a huge number of input data is being carried out and also acted upon. Solution in this case is a natural language processing algorithm which are capable of understanding the human language. They're able to understand the meaning, the intent, and the sentiment from the data that you expose to them. So in this case, the natural language processing algorithms can be used, and they are able to find out what are the sentiments that are exhibited by the customer's comment or reviews or their request, and what is the topic they are concerned about. Once you have this data available to you as a telecom operator, your teams will be naturally be able to address the urgent concerns immediately, be able to prioritize their work, and also help faster resolution of the issues. So in this case that I'm pointing out, it has resulted into 30 to 40% quicker resolution. So you can imagine it has naturally elevated the customer experience with that operator. In this case also, if you look at how the basic workflow is going in order to develop these kind of system is as following. Number one, you collect data. You collect customer reviews, chat transcripts, your documents, data in the form of text. Once you have this data available to you, you train a natural language processing model that are able to understand the language pattern, sentiments, and the topics and the intents that are exhibited in the example that you shared, and thus they are able to process on similar kind of data that they haven't seen before. So once this training is done, when a new customer review or a complaint comes in, the natural language processing based AI system processes them, and in real time be able to classify those problems with respect to the sentiments that are exhibited, with respect to the topic that are exhibited there, and allows your team to take actions. So this is a common workflow as you would see in the case of machine learning also. Always there are three steps. There is data involved, there is training, and finally there is an action. Well, in this case, it is also worth point out that you may not always want to train a new model as far as natural language processing is concerned. In the market, there are algorithms which have or pre-trained models that have already seen millions of records, and they have the ability to understand this kind of language and also the the topics that you might be working with. But if you have a custom requirement, you might want to train a new one or built on top of an existing pre-trained model. The next domain is computer vision. So as I explained earlier, if you're dealing with the problems concerning images and videos, then computer vision is the domain that you're looking at. So in this case, the example that we take is from a manufacturing industry, and the use case is visual defect detection. For manufacturing companies, as you can imagine, they deal with physical objects and their processes are physical. And one such example being visual defect detection, where looking at the part which goes into assembling a product and finding out whether that part is of good or a bad quality is an important task. So doing the defect detection is one of their core operations. So challenge here is a manual inspection is slow, at times it is error prone, and imagine a scenario when it has skipped such kind of detection and has eventually went into a product's build, then the company has to pay for the replacement cost, and also that results into brand damage. So this is the challenge with the manual ways of inspecting the defects. The solution that comes in here is a high resolution cameras and AI models that are rapidly able to classify products as defective or acceptable. Once you have this kind of ability available, then you can imagine the speed and scale at which this operation can be simplified. And the impact in this case was 95% defect detection accuracy with 60% reduction in the inspection time and obviously fewer warranty claims. So you can see the benefit is very, very evident. If you look at the workflow in which computer vision systems are built, you will see a similarity again. The first task is to collect the data. So in this case of defect detection, we will have to collect the images of all the parts of the product that are contributing to making of the product and capture their variation in the form of good products and bad products. Once you expose this data to the model will find out the patterns that are exhibited in the good parts and the patterns that are exhibited in the parts which are having some sort of anomalies or defects. Once trained, the model can be exposed to new set of images and it will find out if that image belongs to a product with good quality or with the bad quality. So in this case also, we have a choice either to train our model fully if our requirements are very, very customized. But in the market, there are already pre-trained model availables, which have also seen millions of such images before, and they know to a great extent what those images mean and have the natural ability to classify or detect objects in them. Moving on to a last domain, which is generative AI. So, as I said earlier, generative AI brings in a paradigm shift. Compared to machine learning, natural language processing, or computer vision, they go beyond the ability of analyzing things and making predictions, but they delve with creating content on their own. The content like text, images, code, designs, and things like that. Now, the use case that I picked up here for explaining this capability, how it is used in the industry, is from marketing department of a company, where generative AI is used for generating the content pertaining to a product's description. So, typical challenge that marketing teams face is they struggle to produce high volume of engaging on-brand content across diverse channels and maintaining the quality along the way. So you can imagine the manual efforts in this case are also slow and obviously are unescapable, scalable. So in this case, the solution is a large language model that automatically generates diverse content from marketing copy based on structured data and the brand guidelines. So you can see the impact in this case was 5 to 10 times faster cycle of producing these product content, which otherwise manually would have taken a lot of time. And you would also see it's all happening at a scale. The way these systems are built are slightly different to what we've seen earlier. The input in this case, particularly the example that I've taken using the large language model, the input here is in the form of prompt. The prompt is something that is written instruction that you write and give it to the model. So model understands your requirements. So in this case, we can write our prompt that describes about the requirement of writing a product's content, as in what format to follow, what style to follow, what tone to follow, and club some of the examples so that model can fully understand our requirement. Once this prompt is built, the model looks through that prompt, that we call that as a training process of the model. Once the model is trained, the model is able to generate the product description for the products that it hasn't seen before. So you can see within no time, the model is capable of generating high quality, consistent, brand aligned product description for huge number of products that otherwise would have taken a lot of time. So that brings us to our final part, let's go through this table where I try to segregate the business problem types and map it to the AI solution. So in a nutshell, I can say that if your problem is to deal with numbers, for example, predicting numbers or predicting categories of the event based on those numbers, then your solution is machine learning. Moving on, if your problem is to deal with human language text, then natural language processing becomes your solution. If your problem is to deal with images and videos, then computer vision is the solution. And finally, if your problem is to deal with generating new content, then generative AI is the solution for you. I hope this map is being useful and you will be able to utilize this information next time when you tackle a AI problem. I'm sure you get the starting point right. Thank you so much for going through this discussion. I hope this has been useful. This is my first video. If you like my content and if you like the way I presented it, please like this video, share with your colleagues, and also subscribe to my channel as I plan to bring up more and more videos so that we bring artificial intelligence and its capability to home. Thank you so much.